Hello everyone. In this session, we are going to solve one more problem on Nyquist plot. How to draw Nyquist plot for the given g of s using Nyquist criterion and determine the limiting value of k for stability. So this is the given problem. G of s equal to k into s plus 4 by s into s minus 2. S into s minus 2. So from this problem, let us write the number of poles and zeros and those values. So here only one zero is existing, that is minus 4. It is on left hand side and two poles are existing. So first pole value is 0 existing at origin and the second pole is plus 2. So existing on right hand side. This is the data regarding poles and zeros of the given g of s. Now we are going to write the steps to plot the Nyquist. Step 1. Step 1. Write g of s in 1 plus st form. G of s in 1 plus st form. Okay. So now the transfer function can be written as g of s equal to, take 4 common in the numerator part. So 4k into 1 plus 0.25s by, in the numerator part, take 2 common. So 2 into s and this becomes minus 1 plus 0.5s. Now we can write the simplified expression g of s equal to, cancel 4 with 2. Now we left with 2k into 1 plus 0.25s by 2s into, sorry, we cancelled 2 already, s into minus 1 plus 0.5. Yes. Next step, step 2. So step 2 is put s equal to j omega in g of s expression. Okay. So now g of j omega equal to 2 into k into 1 plus 0.25 j omega by the denominator portion j omega into minus 1 plus 0.5 j omega. Plus 0.5 j omega. Okay. So now step 3. So in step 3, we have to find the magnitude and phase of g of j omega. So find magnitude of g of j omega and phase angle g of j omega. Okay. So now write the expression modulus g of j omega. Modulus g of j omega equal to. So observe, this is constant 2k, means it is a pure real number. In this, imaginary part is 0. So root over 2k whole square plus 0 square remains 2k only. For the next term in the numerator, 1 plus 0.25 into omega whole square. For the denominator portion, this is pure imaginary term, real portion is 0. So root over 0 square plus omega square gives out omega only. Root over, for the next term is what? Minus 1 whole square means 1 plus 0.5 omega whole square. 0.5 omega whole square. So this is magnitude of g of j omega. Next, we'll try to find phase angle of g of j omega equal to. So for this term, so what is the phase angle here? Tan inverse imaginary by real. So 0.25 omega by 1. In the denominator portion, it is pure imaginary number. So for this, what is the phase angle here? Tan inverse imaginary by real portion is how much? 0, means tan inverse infinite, plus for the next complex term, observe this one. This is complex number lies in second quadrant, means real part sign is negative and imaginary part sign is positive. So minus plus lies in second quadrant. So for this, the phase angle is 180 degrees minus tan inverse imaginary by real. So tan inverse 0.5 omega by 1. 0.5 omega by 1. So write down the simplified expression. So angle g of j omega equal to tan inverse 0.25 omega. Here denominator portion, it gives minus 90 degrees minus 180 degrees minus tan inverse 0.5 omega. Okay, so minus 90 minus 180, the angle value is minus 270 degrees. So tan inverse 0.25 omega minus 270 degrees minus tan inverse 0.5 omega. Okay, so from these two equations, means from the magnitude equation and from the phase angle equation, we need to find the values at omega equal to 0 and omega equal to infinite. Step 4. Find the magnitude and phase angle at omega equal to 0 and at omega equal to infinite. Let us find at omega equal to 0. So what is the magnitude value and what is the phase value? So this is the magnitude. Substitute omega equal to 0. So we have 2k by 0 means infinite. Omega equal to 0. So the magnitude value is modulus g of j omega. Modulus g of j omega. So value is how much? 2k by 0. So that is infinite. Okay. Now find the phase angle. Angle g of j omega. Angle g of j omega. So substitute omega equal to 0. So this gives tan inverse 0. Here also tan inverse 0. So we left with minus 270 degrees. So the phase angle is how much? Minus 270 degrees. So let's combine these two, means magnitude and phase angle at omega equal to 0. At omega equal to 0. So the magnitude is infinite and the phase angle is minus 270 degrees. Okay. So like that, find the phase angle and magnitude value at omega equals to infinite. So modulus g of j omega equal to 2k by infinite, it gives 0 and angle g of j omega. Substitute in place of omega infinite value. So this is tan inverse infinite and this is also tan inverse infinite. So plus tan inverse infinite and minus tan inverse infinite get cancelled. Sorry, here the equation is minus 90. Okay, minus 270 degrees. This equation is minus 180 degrees. This is minus tan inverse. Take to the numerator. So this is plus tan inverse 0.5 omega. This is also plus tan inverse 0. Omega. So now substitute omega equal to infinite here. Infinite here. Okay. So this value is tan inverse infinite and this value is tan inverse infinite. So how much? 90 plus 90, 180. 180 minus 270 degrees. 180 degrees minus 270 degrees. So this results minus 90 degrees. This results minus 90 degrees. Now let us combine these two equations. Let us combine these two equations. Omega equal to infinite. Now the magnitude value is 0 and the angle value is minus 90 degrees. Now in the next step, let us plot the Nyquist. Step 5. Let us plot the Nyquist plot. Nyquist plot. Okay. So this is 0 degrees. Move in clockwise direction minus 90 degrees and this is minus 180 degrees and this is minus 270 degrees. minus 270 degrees. Now in the previous we calculated at omega equal to 0 and omega equal to infinite, both the magnitude and phase values, what we got? Infinite angle minus 270 degrees. Minus 270 degrees. So minus 270 degrees appears at the upside. There we assume infinite point at infinite at minus 270 degrees. V reaches to 0, means from infinite to 0, from infinite to 0 through minus 90 degrees. Through minus 90 degrees. So from infinite to 0, it reaches 0 through minus 90 degrees. So Nyquist plot, we have to plot from omega equal to minus infinite to infinite range. Already we have calculated from 0 to infinite. So obviously we can draw the mirror image from minus infinite to 0. Okay. So we have to start at infinite at the side of minus 90, and it passes through minus 270 degrees, and it has to reach 0, and it has to reach 0. So let us observe the path taken by this. So it starts from here, travels like this, and like this, and exits like this. So it ends at this point. Now here we have to find the point of intersection here. So we have to find the point of intersection here. Okay. So later we'll calculate this one. And from the given G of S, we know one pole existing at origin because it is type 1 system, means it is S power 1. So we need to draw at the ending from end point 2 to the starting point. We need to draw a line like this because it is a type 1 system, S power 1. We need to plot one line from ending point to starting point of the plot. So this is the Nyquist plot for the given G of S. It is not over. We have to calculate the intersection point. So for this, step 6, equate the phase angle equation to 180 degrees. Equate phase angle equation in order to calculate the intersection point equation to minus 180 degrees. So what is phase angle equation here? This one, tan inverse 0.25 omega minus 270 plus tan inverse 0.5 omega. So minus 180 degrees equal to tan inverse 0.25 omega minus 90 degrees minus 180 plus tan inverse 0.5 omega. Here minus 180 and this minus 180 get cancelled. So 90 degrees equal to tan inverse 0.25 omega, tan inverse 0.25 omega plus tan inverse 0.5 omega. Plus tan inverse 0.5 omega. So from this, we need to calculate omega value. So for omega, we need to apply trigonometric formula in order to solve this equation. So apply tan on both sides. Apply tan on both sides. So this becomes tan 90 degrees equal to tan of tan inverse 0.25 omega plus tan inverse 0.5 omega plus tan inverse 0.5 omega. Okay, so it looks like tan A plus B equation. Tan A plus B. So what is tan A plus B? Tan A plus B. Tan A plus tan B by tan A plus tan B by 1 minus tan A tan B. 1 minus tan A tan B. Now let us solve this one. Tan 90 can be written as, so tan 90 is infinite. It can be written as 1 by 0 equal to, so this is A and this is B. Apply this tan A plus B formula for this equation. So we left with tan of tan inverse. Tan get cancelled. Here also tan of tan inverse. So 0.25 omega plus 0.5 omega by 1 minus 0.25 omega into 0.5 omega into 0.5 omega. Now cross multiply. So 1 minus 0.25 into 0.5 into omega square equal to 0. So from this, omega square value is 8. Omega square value is 8. Now substitute this omega square in magnitude equation. Substitute in g of j omega equation. Modulus g of j omega equation. Okay. Now modulus g of j omega equal to 2k root over. So what is the equation? Let us check. 2k root over 1 plus 0.25 omega whole square means 0.25 whole square into omega square. Omega square value is 8 by root 8 means omega value root over 1 plus 0.5 omega whole square means 0.5 whole square into 8. This is equal to 2.449 K by 4.898. So this value is 0.5 K. So magnitude value is 0.5 K. So let us place this magnitude value in the intersection point. So the plot exists in left hand side. So the value is how much? Minus 0.5 K. So this point is how much? Minus 0.5 K. 0.5 K. So let us assume if the given system is stable. If the system is stable, what is the range of K? What is the value of K? If system is stable, let us assume if the given system means G of S is stable, what it needs to satisfy? It needs to satisfy capital N equal to P minus Z. Capital N equal to P minus Z. So what is N? Number of poles encircled. What is P? Number of poles lies on right hand side. What is that? Number of zeros lies on right hand side. So here N equal to what is P minus Z value? So number of poles on right hand side is, so how many poles? Only one pole, and 0 is 0. So N equal to 1 means only one pole lies inside the circle. Should be lies inside the circle. So if one is inside the circle, then only the given system is stable. So when compared to this point is outside. This point is outside. Means this value is definitely less than minus 1 value. Less than minus 1 value. So here minus 1 plus j0 lies inside the circle, then only capital N value is 1. Then only capital N value is 1. So when you compare to this point to minus 0.5k, definitely this minus 0.5k is less than minus 1. Then only the system is stable. So now consider this condition. So definitely for a stable system, minus 0.5 k should be less than minus 1. So from this the k value. So k is less than 2. K is less than 2. So when k is less than 2, then the system is stable system. Then only it satisfies this stability condition, means N equal to P minus Z. N equal to P minus Z. So other than those values, the system is unstable. Other than those values, the system is unstable. Means this minus 1 is not encircled. There N equal to 0. There will be N equal to 0. So other than k value, other than k values, the system is unstable. The system is unstable. So then here capital N is not equal to P minus Z. So there capital N equal to 0 because it is not, the pole is not encircled, and for the system number of poles are 1 and that too that pole is lies on right hand side. So their P value is 1 and 0. So no 0 is lies at right hand side. So Z equal to 0. So here this N equal to P minus Z. So here P minus Z value is how much? 1. So other than K less than 2 values. Means for for K greater than 2, the system is unstable. So this is the solution for the given problem. So how to find the unknown value of K for a stable system by using Nyquist criterion. Thank you guys. Thank you for watching.